Um, Thank you, and great to see so many people so early in the morning. Greetings. My name is Ying. I'm a lead convener of the Applied Urban Modeling Symposium series, and here is my great honor and pleasure to open this workshop series, and very appropriately in Oceania, in Australia, in particular, where the working day starts globally. And on behalf of the scientific committee, which consists of Professor Michael Batty, Professor Marcia Eschenik, and Professor Michael Wagner, and also my fellow conveners of the symposium, I would like to welcome all of you to this online global workshop. And this is still a new idea, relatively, in the world of symposiums. So this is going to be an online workshop that's going to last for 10 sessions, each 2 hours. There will be 20 hours, which exhausts more or less of the global day of the 28th of January. And the idea is really to invite colleagues who are really dedicated to the development and the delivery of new analyses and modeling for practical purposes for cities. And you will see that it will take many different forms, and it also will take many different kind of perspectives to see problems. And this is precisely what we want, because what we would like to see for this day is really for people in their local regions to talk about the challenges they have felt most keenly, and also to propose their approaches to deal with these challenges. And over the whole series, then we will be able to look at the kind of challenges that we face in different regions. As still a very selective sample, because we have actually chosen the very best papers that have come in curating the session. But I hope it's a very enjoyable session or sessions that will go through Oceania, then Asia, then Africa, then Europe, and then to the Americas. Now, so of course, the expectation is that nobody was going to watch everything like this. The idea is really, as the world turns to the sun, the local regions and their nearby time zones will watch the discussions and participate. And then those who cannot actually, the session that people cannot attend, then they can watch online, because this whole thing will be recorded and then uploaded onto our AUM webpage. And also, we have run this session in a meetings format, which means that everybody can see everybody else. They can also chat, both publicly, also chat individually to each other, actually, to discuss. And it's really good actually to see so many people, as we cannot travel at the moment. But there's a one health warning that don't watch for too long, because do save some for the videos, because otherwise you might get a feel of jet lag by not traveling and working from home. Now, for the questions, we very much like colleagues to participate in this format. And the two ways to do questions, as generally you probably have already well practiced. One is to raise your hand, and you'll be invited by the convener to ask questions. And you can switch on your audio and visuals, and then ask questions and just talk to the colleagues. Or alternatively, you can also do the chat, and then the convener, discussant, and the host will monitor these chats and pass these questions for the discussion. Right. So without further ado, and I would like to introduce the convener of this first session. And it's my great pleasure to introduce Professor Christopher Pettit, who is the professor and the inaugural chair of urban science in the University of New South Wales, and also a leading figure in the Coupon conference series to introduce the session and introduce the speakers. And so, Chris, it's over to you.
Thanks, Ying. So welcome everyone to the first session on city analytics. Now I do just have, am I able to share my screen to show some slides, or is that it's coming up that it's disabled?
It should be enabled now.
Ah, fantastic. Okay, so can everyone see those slides?
Yes.
So
now
thanks.
Presentation mode.
Excellent. So thanks, Ying. It's our honor and pleasure representing Oceania, well, predominantly and exclusively at the moment, Australia, I must say, to open this online global workshop. And so thank you, Ying, and the Martin Centre at University of Cambridge for organising such an amazing event. I mean, 10 hours. I mean, we could be binging on applied urban modelling. And as you said, we probably need to make sure we take some breaks and come back and look at some of the sessions. And so we're very honoured to be opening the global online workshop. I've had the pleasure of attending a couple of these applied urban modelling conferences in Cambridge with Ying and colleagues over the last decade or so, and they're an excellent event. And I'm somewhat remorseful with COVID, as in a lot of the conferences now, pretty much all of the conferences we can't attend in person. So I guess this will have to suffice that we can meet in this online Zoom environment. And I guess that's one of the challenges we're facing, and a number of the presentations that we'll have from my colleagues across Australia will be looking at, how we look at harnessing the power of applied urban modelling to deal with the challenges facing our cities and society under these challenging times when we have COVID. We have a changing climate. In the context of Australia, we just came out of the bushfires in early 2020. Some of the worst bushfires in the world has ever seen. And we thought that was a challenging enough event. And then, of course, we went straight into dealing with COVID. So it'd be good to see how we can sort of harness the intellect and capability we have across our urban geographers and modelers to inform our policymakers, our decision makers, a number of whom are now looking at using analytics, looking at using dashboards and looking at the evidence more critically. Some are not, but maybe there's a tide changing in certain countries that we can play our role. So this session, the next session, is really focused on city analytics, which one definition is that it really is a digital toolkit comprising a set of frameworks and methods to support collaborative city planning and user-centered design of our cities and urban places. So that digital toolkit can comprise models, simulations, visualizations, systems thinking frameworks like geodesign and so forth. So that's the theme. And so there's a number of presentations from my colleagues looking at a range of methods, models, and techniques that I'll introduce in a minute. And so how do we start to bring to bear some of that evidence, like this COVID dashboard out of this Value Australia project, where we can bring this information and the analytics and make that available to the community policy decision makers. And so this is a dashboard we've put together in response to COVID, bringing a property view and overlaying that with a COVID view of the world. And so the role of these dashboards, which are underpinned by robust analytics and modeling and simulations. I will just say a couple of words, Ying, if I may, about COPM. So as chair of the board for the Computational Urban Planning Urban Management conference, which is a sister event and society, and we usually run, and we do run in parallel every second year to applied urban modelling, which the main sort of sessions for applied urban modelling were 2020. This year we have COPM 2021, which our colleagues in Helsinki, Aalborg University, are hosting. So I see a number of participants here have papers, and we invite you to participate in this COPM event in June 9th to 11th, 2021. It will be a hybrid conference. For those who want to venture to Helsinki or can venture, then you can attend in person, and if not, there'll be an online opportunity. So Ying and I are also talking about a joint event run by Applied Urban Modelling and COPM for the early career researchers. And so we'll provide more information about that as they arise. Okay, so it's my great pleasure to introduce our presenters. So we've got 3 excellent presentations today from a number of universities across Australia, and also our discussant, who will be chairing our questions, our Q&A session in this format. So we have 3 presentations from Professor Jonathan Corcoran kicking off. So Jonathan is a professor at University of Queensland, and he has been there since about 2005. He's the director. I haven't got my notes directly in front of me, Jonathan, so correct me if I need to. The Population and Demography Centre there, and is a lead urban geographer involved in a number of initiatives, and has a number of roles in peak international bodies around, I think the Royal Geographers Society, and also Institute of Urban Geographers. Is that IAG? IUG?
International Geographical Union. So yeah. IGU.
That's right. I'm dusting off some cobwebs. It's our first international event. And so yeah, Jonathan does a lot of excellent work up there at University of Queensland with his centre, with his colleagues, looking at some of the challenges. So here's a presentation on familiar strangers in urban analytics, mapping, measuring and monitoring. Then we'll move to my colleague, Associate Professor Hoon, University of New South Wales, who is still director of the city planning program, about to transition to focus more on his research. And he's also one of the chief investigators on the Value Australia project. So Hoon will be looking at some of his research, looking at cellular automated models and so forth, looking at industry mixes. We have Dr. Somwrita Sarkar, University of Sydney, and Somwrita will be looking at her presentation on polycentric urban growth and the evolving access to jobs and social infrastructure and the role of new data sources, implications of unexpected extreme events, e.g. COVID-19. So an interesting title for a paper there, a lot in that title. And Somwrita does excellent work in looking at complexity in cities and complex systems, has a background in urban planning and modeling. And very pleased we have our discussant who will be leading our Q&A session, Professor Sharon Biermann, who is the director of PATRIC, which I think is the Planning Transport Centre, which brings, I think, at least 3 universities, is that right, Sharon, together to look at collaborative planning approaches, data-driven approaches to dealing with issues facing our cities, including Perth, the capital city of Western Australia, and other cities. So I really like to thank my colleagues, presenters, and our discussant, for making the time and sharing their presentations with us today. So I think we each of you have about 15 minutes, as Ying was saying, for your presentation, some quick questions, and then most of the questions and discussions will happen after the 3 presentations. So Jonathan, over to you.
Thanks, Chris. Can you just unshare your screen and I'll be able to. Does that come up for you now?
Yes.
Yes.
Absolutely.
Okay. Excellent. So thank you, Ying. Thank you, Chris, for the opportunity to talk to you today. It's a somewhat rather curious title, I expect to most, Familiar Strangers in Urban Analytics. And what I'd love you to do for the next sort of 10 or so minutes is to indulge me and think for a moment of a regular, and I suggest probably a pre-COVID day in your life, and consider those people that you encountered during those daily activities. And those are specifically people who you recognize, but have never spoken to. And so that's what we'd consider the familiar stranger. So I'm expecting most of us live in an urban environment. So these sorts of daily experiences of seeing people that you've never spoken to, but recognize, the lady at the coffee shop or the guy that gets on the train, you recognize them in our regular everyday encounters. And so for the next 10 minutes, what I want to do is take you on a little bit of a journey of this kind of curious, but what's suggested as a frozen world of the familiar stranger. And so for a moment, before we get chatting about the familiar stranger specifically, I want to start by considering this rather nebulous concept. We've all come across policy documents that sort of talk to the livable city. And for those more, or those that live in Australia, you might recognize the image that you see on the right-hand side there. So the city for that pertains, I'm not sure we've got any people, certainly not presenting today from there. This is Melbourne. They were knocked off their #1 spot back to #2 as the most livable city in the world. And so the Economist Intelligence Units, they do this kind of exercise whereby they look across 30 factors and they rank cities based on a whole series of things. And then this sort of folds out that Melbourne, according to these 30 factors, is the second most livable city in the world. But I want to reflect on the statement at the top by Ottersman, and it comes at an interesting point in sort of geography, which was the humanistic turn of the 1970s. And I think it's really applicable to the way in which things are moving today in the urban analytics space and the origins of new sorts of data sources that for the first time allow us to do exactly what Ottersman was talking back in 1975. So he was saying that if we're going to understand cities and how cities work, the patterns of activities, we actually need to understand how urban residents singly and collectively engage. And so to do that, we actually start needing to unpack how social and physical elements of urban life interact and how physical features that our urban spaces are comprised of act to frame how we do things, when we do things, and how we transit between these particular types of places. And so in thinking in that sort of framework of livable cities, I'd suggest that where we're at the moment in terms of how cities are ranked, we're yet to get to the point where we've got this humanistic component, this individual lived experience of the city embedded in terms of how cities are kind of measured. And so how we're actually measuring and ranking things is yet to really engage with these emergent sources of data. And so what I'm going to talk to you in today's presentation is how we can start to think about a really important element of a livable city. And again, thinking of your own experiences, this is the best lens, I think, through which we can kind of gain an appreciation of this. So again, I want you to kind of go back and reconsider that regular pre-COVID day and the sorts of experiences that you typically have on that day, and what might the social consequences be for the sorts of people you engage with on that regular day and the sorts of places that you intersect with whilst completing your routinized activities. And so thinking about our urban world, we know it's comprised of a large mosaic of places, whether you're in Beijing, Shanghai, Cambridge, Sydney, Brisbane, and so forth. There's the train station, the coffee shop, the office, the supermarket, the shopping mall. These are places that we might visit on a regularly routine occasion. And it's those interactions with those places that result in these temporary population flows. And so each place has its own intrinsic ebb and flow of populations coming and going as places open and close, as offices start and finish. And it's the thing I want to talk to you particularly about today is the social consequences. I'm going to focus on the antisocial consequences, but equally, there's the pro-social side to this as well. And so these daily population flows through train stations, coffee shops, offices, supermarkets, and shopping malls give rise to opportunities for pro and antisocial activities. So if we're thinking about crime as the antisocial consequence, people being or not being in a place effectively create opportunities or remove opportunities for crime happening, as the presence or absence of offenders, guardians, and targets vary across the course of the day. So again, thinking about your regular day, what does that actually mean? So at this point, I want to come back to the familiar stranger. So what are they? I sort of briefly explained these are individuals that you recognize, but have never visually recognized, but you've never actually formally had any verbal interaction with. We all know them in our daily lives, who they might be. And so these are repeated cursory encounters. So why might they be important for crime protection? And equally, why might they be important for livable cities? So scholarship that has been for approximately 100 years now in the social sciences suggests, but has had very minimal empirical testing, the increased familiarity among individuals. So there's a suggestion that if there's an increased density of these familiar strangers at a given place, they might have social benefits by reducing individual anonymity, enhancing moral obligation to obey behavioral norms, which in turn could have a crime protection effect. So familiar strangers are a good thing. So if we know and recognize people in a space, or if we recognize people in a space, that might actually have a social good. So where does all this come from? So there's probably a reasonably well-known piece that's come from urban sociology. A guy called Stanley Milgram back in 1972 did a study in the US, a kind of fascinating study to reflect on. So the image that you're seeing in the background there with people with numbers around them. So what Stanley did back in 1972 was go to several train stations and take a photo of people standing on the station. And then 1 week later, went back to that very same train station and went through each individual asking, who do you recognize in this picture? And 89% of the people across all of his study recognized at least one other individual in their photos. So there's some indication that our routine activities, in this case, in the transit environment, there's quite a lot of familiarity, and we can again reflect on our own experiences when we go on the train trip or when we go into town. There's probably people that we recognize but have never spoken to. So what I want to show you next in the next few slides is trying to sort of build on Stanley's 1972 study, as well as other studies that have started to unpack and realize the utility of Wi-Fi data, of transit smart card data, and of mobile phone data. And to understand what are the social consequences for this. And so what we wanted to do here was unpack population presence or familiarity at transit stations and understand whether or not, or the extent to which it had a crime protection effect. And so that's what we did by looking at property theft, drug and good order offences for bus stops across Brisbane. So our study context, just to give people a little bit of background in terms of where we're operating, little thumbnail up in the top or in the middle at the top, that's Brisbane over on the right-hand side in the middle of Australia, and Queensland itself, so the whole state that you're seeing on the big map on the right-hand side, about just under 5 million. Southeast Queensland down in the red box there is about 3.5. The study space that we're talking about today is around about just under 2.2 million. That's Brisbane with the red dot there. The units of analysis, so the sorts of data that we're using. So mesh blocks are a census product. So in the Australian Bureau of Statistics, the census, that's the finest spatial unit at which data is available. And so we're interested there at sort of land use. And so we're able to get different indications of what the land use is for a relatively small block of space. We then got crime incidents by day for our study space, and then passenger flows, which we derive from smart card data. So in terms of our analytic approach, so what you're looking on the right-hand side there, that's one of our main sources. And I think from an urban analytics point of view, it's a source of data that's becoming more and more used, and its utility and the sorts of questions it's able to answer is expanding. And hopefully the paper I'm presenting today will sort of help to sort of unpack its utility a little bit more. So we had 12 months of this smart card data. So to give you an idea, when you tap on or tap off of any public transport in Brisbane, it records as a data point. And so to give you an idea, it's quite a large data set. 12 months is around about 5 gigabytes in size. And for each day, there's about 700,000 transactions. So that's every tap on and tap off of a bus, a train, or the ferry. They're the 3 public transport options in Brisbane. So we're deriving passenger presence. So that's daily passenger flows. We're also interested in the immediate bus stop environment. So that's within 100 meters of the bus stop. Then we're interested in the walkable area around that bus stop. And finally, the neighborhood structural characteristics. So for 2, 3, and 4, we're getting that sort of information from the census. For 1, we're getting that from the Go card data, the smart card data, and also we've got crime as a 5th type. We're interested in 3 types of crime: property theft, drug offences, and good order offences. And analytically, we're applying spatially nested negative binomial models with robust standard errors. Haven't got time to go into sort of the specifics of the empirics, but hopefully that will give a little bit of a sense about the nature of the types of data and the analytic technique used. So the first thing to do really was saying, how many familiar strangers and what's the intensity of familiar strangers across our study space. So the little 4 maps that you see there gives an indication of the array of familiarity in terms of presence. So we're looking relative to all passengers. So the top left would indicate for those red lines is about 12% familiarity. So approximately 12% of people that are traveling along that particular bus line have traveled, they're regarded as familiar strangers. And so in the context of our analytics, a familiar stranger is defined as 2 individuals who encounter each other 2 or more times across our 9 candidate days. And so because the data is really lumpy, really difficult to process, and this is one of the things that we're working on at the moment, we have to have candidate days because the computational requirements are really quite ugly. So we have 5 weekdays and 4 weekend days. So to give you a sense of how many encounters occur, just under 3 million encounters happen across our 5 weekdays, and just over 250,000 across our 4 weekend days. So it's quite big, lumpy data to get to. And from that, we can start to sort of see what does that familiarity look like on weekdays. So approximately 60% of all trips that occur in Brisbane record at least 1 familiar strangers, and that presence lasts for about 17 minutes. So people travel with other people that they recognize for about 17 minutes. It's less at weekends, approximately 40%, and for a shorter period. So the average co-presence is about for 13 minutes. So that's a descriptive. We're able to sort of map this and look at how that shifts over time. But coming back to our question of crime, does it matter for property theft? Does it matter for drug offences or good order offences? The short answer is yes, it does. So all of the modeling suggests that the intensity of familiar strangers, so having familiar strangers is a good thing. It reduces crime across those three types. And we'd argue how that would have a buffering effect. So knowing someone, there's a more likelihood, there's a willingness to intervene in a problem like it when it occurs. So on average, at bus stops, where there's high concentrations of FS, familiar strangers, there's fewer counts of those three crime types. Theoretically, we argue this is leading to lower crime by reducing anonymity in that particular space, which in turn increases moral obligation for behavioral norm adherence, and therefore reducing offending or enhanced guardianship capacity, either or, by encouraging surveillance and intervention in problems when they arise. So it was an all-round positive. So familiar strangers has a positive effect in terms of that antisocial component, in terms of reducing crime. I'm conscious of time, so I'm not going to go any further talking about the analytics. More to say that a behavioral approach that engages with new emerging data, such as smart card data being one exemplar source, Wi-Fi data might be another source, mobile phone data, you can do similar sorts of things. But I'd argue that as cities, we're striving to try and reconfigure them in a manner that invokes higher levels of sustainability and individual well-being. So if we're going to start to inform the smart redesign of areas or places, then we start to have to understand how our daily lives intersects with those places and how those places have both pro and antisocial consequences that play out over the course of the day, the week, and the year. And given that encounters are the very source of social relationships, and repeated observations, as we've seen from our analytic work so far, are really crucial for the development of social behavioral norms and for pressing back negative things like crime. We start to have to engage with this idea of mapping, measuring, and then monitoring familiar strangers. We've only looked at transit networks. We're sort of exploring different sorts of public spaces at the moment using alternate sources of data. And so we're looking at repeat encounters in different sorts of spatial settings and at different temporal granularities. So as I probably alluded to, one of the most difficult things at the moment is the computational requirements for looking at familiar strangers. It's really wormy, it's really difficult to do. And so we're building a scalable method that uses parallel processing techniques. We're building that in R, so we're looking to then port that so others can apply that same approach to other transit networks and using similar sorts of data. And we're looking at the stability change component over longer periods of time other than our 9 candidate days. And on that point, I think what I'll do is stop and sort of hand over to Sharon to handle any questions. Hopefully that was around the 10-minute mark. So just some references, if you're interested in that, we've published a number of pieces. I failed very miserably to acknowledge my excellent co-authors being Renee Zarnow, Min Zhang, and Jianping Zhou. So Min and Renee are both at UQ, and Jianping Zhou is at Hong Kong University. So thanks to all of those co-authors that have helped shape this body of work moving forwards. Sharon.
Good, thanks very much, Jonathan. That was a really interesting viewpoint, and I've certainly, it rings so many bells in terms of what I experience when I travel on the train particularly, and also walking the dog in the park is another area where one really does pick that up, and I think the safety perspective is really interesting. So we can leave all the really deep questions until later, but does anybody have any questions of clarity? Jonathan briefly went over the methodology. There might be some clarity on the method that might be important. Now, how will I see if anyone's got their hands up? You can either drop a question in the chat box or put your hand up, and Ying will help me, I think, to identify if anyone's got their hands up. Has anybody got a question for Jonathan?
I haven't seen the hands up yet, and they could also chat. Maybe this is still a little early days yet. And Chris, do you have any questions?
I'm happy to ask a question.
Thanks, Michiel.
Yes, so I'm wondering if familiar strangers are a good thing. Is there some way to improve or increase familiar strangers through certain policies, with certain time schedules, slot allocations, or can we influence it?
So I think there's a question, I might roll them together. There's a nice question in that asks about eyes on the street and the theory by Jane Jacobs. And I think that comes to your point, Michael, in terms of precinct design and urban planning and the role that urban planning can play, as well as design, in thinking about collections of places that together would result in a continual flow of people, and thus familiarity could kind of be maintained over longer periods of time, rather than what we see in a transit setting, and a transit setting in isolation, where you have pulses of familiarity. So familiarity would typically pulse in the commute periods, whereas outside of that, familiarity would kind of wane. And so thinking about a precinct design, that it's not just about the transit station, but it's the transit station environment, the coffee shop, and the other things that are co-located. That's a really kind of a more powerful kind of approach to thinking about maintaining and intensifying familiarity, given we know it's got pro-social benefits.
Thank you.
Thanks, Michiel. Then there's a question from Claire, which talks about the number of variables that you've used in your analysis, and whether you would use other variables if you had data.
I think from empirical searches, there's always a need for more data. And I think, there's different sources of information, certainly on the familiarity. And so if one in Australia was able to get down to individual level mobile phone data, or even Wi-Fi data. So thinking about university campuses, accessing individual Wi-Fi records, those sorts of data sets certainly would extend beyond the ability to just look at in isolation at transit environments. And I think that's our goal in the longer term, to add that, as well as the characteristics of space. And so we can get quite a lot from land use data. But one of the really interesting things that we're trying to explore, and again, data is that really kind of big obstacle, is change. So what if a new coffee shop, what if a new shopping center is planned and is installed? What does that do in terms of the social shock to that particular local precinct? Does it have a positive impact in familiarity that then rolls into how people interact with one another and push back crime? So in short, Clay, yeah, we'd love more data, and we've got sort of ideas, but it's always constrained by the data providers at this stage.
Thanks, Jonathan. And then just the final one of clarification, Somwrita challenges us in terms of too much familiarity could lead to a problem with diversity, stifling diversity. Do you have any thoughts on that, Jonathan?
I think it's a really interesting question, and something that, again, we'd need richer data. And so at the moment, we're kind of, we're able to look at different characteristics of the Go card holders, the smart card holders, so we can understand where there's a dense familiarity of older people versus adults versus children. And so we're starting to explore the nuances of whether you have a sort of a highly intense pulse of young people in an area, whether or not that actually has a negative social consequence, versus the protective effects of older people having an intense familiarity with one another. But it's, again, the characteristics beyond that we just haven't got. So to understand about beyond biological sex, or sorry, beyond characteristics, we're getting information on biological sex, ethnicity, household characteristics, and so forth. It would be incredibly interesting to study, but again, we're sort of stymied at the moment as far as getting the color in the data.
Thanks, Jonathan. I think we'll need to stop there for the clarification. So back to Chris to introduce the next speaker.
Thanks, Sharon. Thank you so much for that presentation, Jonathan. And I think there's probably going to be a recurring theme, I'm sort of guessing, around data and data availability to support your research and others that will present in this session. And I think that might be a lively discussion point when we open up for the Q&A session after the 3 presentations, because I think there is never enough data, but even getting that access to that fine scale data and how we push forward with that. So thank you very much, Jonathan. So our next presenter, if I could invite Professor Hoon to give his presentation titled Vertical Land Use Mix and Industrial Ecosystem. So over to you, Hoon.
Thank you, Chris. Can everyone hear me well? That's good. I think this title is relevant to Professor Jonathan's presentation. We need a bit of travel overseas now, so let's move on. Okay. The research I began with about a couple of years ago when I visited my hometown in South Korea. It was about 10, probably I left about 10 years ago. Then I visited again. One of the things is I noticed that you probably have a similar experience if you visit a country, a city, a long times back. Then one of the things you realize that is such a big changes in urban form, in particularly the density. So for example, it's Brazil. I get this photo, it's 1970. And this is the same place, the same beach, the densities changes dramatically, okay? One of my research interest is that we know that this densities increases and there is more population there. But one of my questions is that how they use these floor spaces. This is vertical cities we never seen before. And there are each floor, there are different people living there, different business operated, and this business interact with the other business. So I just wonder, if you look at the 2D dimension, we simply look at whether it's a residential use, commercial use, or industrial use. If you look at this vertical dimension, each floor might have a different economic activities and kind of business behavior. So this is a question is I just wonder whether we could actually predict these types of business occupation patterns, or also wonder if you look at the scene, and one of the images I show here is office vacancies. So there is office vacancies across the city. One particular city is show the high level of office vacancies, and the other office building might have a low. And this looks like random, but if we actually understanding what types of business left that place and what types of new business occupied these vacancies, then they might have some sort of patterns. That's what I try to understanding through my researches. So it pretty much global standard, office building tenancy mix strategies. The owners of building, they always want to lower vacancy rate and try to increase the rent over time, gradually increase. And they try to get contracts as a long-term lease rather than short-term and quick turnover. And once it's actually vacant, they're looking at the new business relatively short time. And also, if you look at the attracting anchors tenant, here's the anchors tenant is something like the global companies or Apples or Samsungs. If you're talking about the shopping centers like Myers in here, Myers in Australia, if you actually have these types of leading business, they might attract other small business into the same building. So that is have a kind of spillover effect. So that is one of the target those lease company always looking at the global firms could lease that buildings. And there is kind of a mixed tenant they prefer, or maybe sometime is not. So it's my research, before we actually understanding, is there any typical patterns of building floor spaces used? Then I introduce new concepts. It's like industrial ecosystem. So industrial ecosystem is a complex system, but once we actually looking at these types of business use within the building in the long term, it's like the price determinant when supply demand determine the price in equilibrium point. It's actually the space is a similar things. It's a long term in the city itself. They might find some sort of sustainable kind of floor spaces use. Maybe this COVID effect might affect other types of business, in particularly face-to-face types of business. That might in the long term is adjustable to the city's office space floor uses. That's sort of a kind of idea is we call ecosystem. But also within the office building, is one particular company might affect other companies. For example, I mean, we usually looking at some sort of, let's say that banking sector, financial sector, they always like to share their floor space with the other accounting sector or lawyers, but they maybe doesn't like to something like the business is something like, the grocery shops or hotel business. So each type of business, they might like to pull other business. They really like to share their floor space with other business, vice versa. They might push other business away. So they don't like to share the building, the same floor or within the building. So the question is, I actually looking at the first question is, what are the changing pattern of industrial ecosystem in Sydney? Then I looking at how actually difference between the horizontal land use, each floor space land use, and also the vertical land use, different floor spaces, they have a different business use, but also if you look at the horizontal dimension, different land and blocks, they might have a different land use. So this is whether there are difference between this horizontal land use and vertical land use is one of my second questions. And my third question, which is which industry should be leased first? If it's vacancies, what is important, or what business we should consider at the first place and lease the floor spaces, and that might affect the other business. And what are the push and pull industry within the office building? Is I actually mentioned that one particular business might pull other business, but other business might they push other business away. So what can we actually find some sort of a golden ratio for industry mix? Is that possible? And possibly we can use AI find a golden ratio, whether the building like should be used as a very homogeneous clustering building, like one government sector occupied the entire building. If you look at the other buildings, there is 100 of different business types occupied within the building. So what are the golden ratio? What is the best mix to minimize business risk, such as lowering vacancy rate and the long-term lease, etc. So this is large of a question. Probably I can't answer all of them. That is my research question begin with. I try to answer a couple of questions here. And I look at this 3 times a series of the database. This is floor spaces, Sydney floor spaces office data set. So each year they actually census, survey entire city's floor spaces, what types of business they occupied, how much space they actually occupied. So And if you look at just the long-term changes here, then it's one of the things you saw, you probably see the label here, but it's simply, you probably notice that the hotel, finance, the technology business, recreation, or education and health types of business is actually, number of business is increased over time, while mining, wholesale, and public admin, so some such as government office, they actually gradually decline. So that is kind of information is showing that. And the second graph is actually showing the actual internal floor spaces used. So actual, the office spaces they occupied. You see they're slightly different, similar, but it's slightly different. Professional job, residential, like a mixed use with residential with office building, that is gradually increased. There are more floor spaces used, residential and professional. And there is decrease in manufacturing sector and transport sectors. But one of the things is you can see a very similar pattern across all business, which is if you look at the workspace ratio, which is the floor spaces per employee, then you see that it's many businesses gradually decreased. Which means it's the overall density of the cities is increased. So the second question is I go through, once we try to understand there is some changes of business use over time, then the second question, what is differences of horizontal land use and vertical land use? So one of the graph, if you see the left-hand side, which is a land blocks, and it's a red color, which is show that the highly heterogeneous land use, many different types of land use. So we use a Hutchman's index, which is basically looking at kind of heterogeneity within the blocks. And if you look at the right-hand side, which is each building, is how the building use as. And those red color, if you see here, that is the highly heterogeneous building. Many office business occupied within the building, vice versa, green, blue area, which is very homogeneous use. So if you see the couple of buildings in green inside here, I just look at those buildings. The main is a government office building, or sometimes one global company lease entire buildings. And if you look at these changes, horizontal heterogeneity over time, and one of the things is I found in Sydney in ecosystem, and there is actually heterogeneity in the building block is decreased over time. You see that those areas is actually very heterogeneous, and you can see the in late time 2019 or 17. And also, if you see that in the building scale, many buildings actually clustered. They tend to use as slightly less heterogeneous. And this also clustering patterns is those anchor business, which is a large floor space occupied within Sydney. As you see that ICT, internet telecommunication business, and the professional and finance, banking, insurance company, there are three major anchor tenants in Sydney. And you see that there are patterns is slightly different, the occupation patterns. If you look at the hotspot analysis, there is some areas that might have a concentrate, you can see the patterns. So this is actually provide a very limited information, because this is basically where is actually business occupied within city. But if you look at the building side, even if you look at the one building, there is a top floor, which is used like a professional, and on the ground level is used as kind of retail shopping center. Then middle, which is pretty much is banking sector, finance. So even if in one building, same place, And if you look at a building vertical dimension, there are many different types of uses. And what are the patterns of this vertical industry mix? For example, we look at these sensors, and we actually get this scenic floor space sensors data, and we make this as 3D images each floor. Then you see that the building, like right-hand side, in the middle, there is hundreds of different types of business. You can see that. While if you look at this building in the bottom center, there's one business type entire floor spaces. So there is a different types of business occupied this 3D dimension, and what are their relationship between. And then are looking at a bit of push and pull analysis, each individual business types, whether they like to pull other business, which I look at the correlation analysis. Then one of the things is actually we found that, and this financial, these three anchor tenants, this banking financial sector, they likely pull other business such as professional business, doctors, lawyers, and scientific business, technological business, startups, and transport and postal warehouse business, and ICT, but they push the other residential use, agricultural use, and electricity use. They don't likely share the building floor space with those occupation types. And also professional types, and they like to share with the finance sector. ICTs is one of the interesting things is they don't like share their floor spaces or building with arts and recreation services and hotel and accommodation. But they love retail sector because IT people work late and they might need a coffee. So this is a kind of, I call Sydney's industrial ecosystem DNA. There are three.
Sorry, excuse me, Hoon.
Yes.
5 minutes, if you could,
okay.
please
almost
kindly.
done. Yep. So this financial sector, professional sector, ICT sector, they push art business, ICT sector, accommodation business. Then financial sector, they push agricultural business, but they attract healthcare business. This is a kind of typical pattern in Sydney office floor space use within the building. And one of the interesting is banking sector and professional sector also likely increase office vacancy rate. So this is using the correlation. As I show here is push and pull correlation, positive and negative correlation. Positive is strong pull, and negative means is strong push. Then we apply the cellular automata model and what is actually building floor space actually used in long term. You see the floor space used in changes. Yeah, so okay. You see that the changes of floor space used using this push and pull correlation as cellular automata models and the rule. So we need to set the rule, and you see that there is some floor space invade other floor spaces, and some business use actually convert to other business types. So this is the second part of research, and after what is next. And Professor Chris Pettit is lead Value Australia projects, and we try to find some AI solution. So this AI solution is not good at the geo design, and you see that this possible the building use within the city, particular Princet, and also the different density, different land use each floor. That what are the optimized kind of building or design and the land use types of analysis we could do. So my discussion is last discussion is here is that we could develop this kind of a toolkit, which is a user might in particular site, they select total building floor space they want to build, let's say 10 story buildings and expected rent per square meters. They put in the option, okay, $1,000 per square meters, and the maximum building height, which is under development control, and the FSR, floor space ratio. This is manually proposed, and the toolkit might suggest, best model design and building or tenancy mix. For example, some sort of golden rule. Maybe 25% is financial sector, 10% should be used as a retail, and 30% is something else. So kind of with a combination of golden rule, particularly are controlled by this kind of a variable, which is the user's preferences. And that is kind of a design for the future I'm thinking about. I'm sorry about a little bit rush, and this is start from kind of little bit broad scale. I'm trying to narrow down this day is ongoing research, but this is kind of research I'm doing at the moment, and I want to continue to do so. And this recent publication this year and last year, and one of my ideas also published industrial mix downtown Sydney urban design. So if you're interested, might have a look further. Thank you.
Thanks, Hoon. So if we continue with the pattern before, I'll just lead you through a couple of questions for clarity. Those visuals are fantastic, Hoon. They really are brilliant. Just to kick off quickly, you talk about a toolkit, and that's your aim. Who would the main users of such a toolkit be? And then please, the rest of you, just keep those questions coming in chat.
Yep. Thanks so much. That's a very good questions. So this study is actually start from about 5 years ago with Chris, and we won the RAISE project, which is an automatic valuation model toolkit project. So we developed and designed the automated valuation model. The toolkit, we actually use a different dimension, number of a bathroom, number of toilet. As you know, valuation, property valuation, we need this land size and bathrooms, garage number. Then there is a toolkit and actually provide estimate the house price. And the similar thing is like we developed the toolkit here, and for the use for the leading lease company, Jones, Lassans, and CBRE, they're particularly interested, and they will have the vacancies and floor spaces, then lease plan, what types of kind of tenancy mix strategy they should develop. And also there is a new building site, urban renewal site to propose a high-rise building. Then what sort of kind of the floor space use, and also building design they should propose. Then these people, these possible stakeholders might say the preferences, something like the maximum floor spaces and that spaces within the particular building site. And also the expected rental income, they changes from $100, $500, $1,000. And also they kind of maximum building height might be 10, 12, 13, but under restriction. Then they try to different types of option. Then kind of suggest that the toolkit, what sort of building design looks like, and also what types of business should occupy within the building.
Thanks, Hoon. And then a question from Claire again around the level of standard industrial classification that you've used. She noticed that you've mainly reported at the most aggregate level. Have you done it at a more disaggregated level?
Yeah, that's a very good question. We try to use the aggregate level at this stage, and we can go further detail classification, which City of Sydney provided, and obviously we expected more computing times. So this is test trial versions. We keep use this or aggregate the categories, business categories. But in the future studies, or yes, definitely we consider detailed building code. Even education training sector, we have a 20 or 30 different types of education and training related sectors. For example, the high school and primary school related, coaching school. There are lots of different types of, but I haven't used this fine detailed business coded, but yes, we can.
Thanks, Hoon. Is there another question, last question for Hoon?
Yep.
I can't see everybody. Were there any more questions? Just unmute yourself and ask. Jonathan, have you got a question? Are you just moving your...
Sorry, adjusting the screen.
Yeah.
Probably a comment or a question, Sharon, is I guess that it links back to the currency of the data and the situation we're in when we start to think about industry mixes and what those industry mixes were before COVID-19 and what those industry mixes and tendencies might be post COVID, when we're starting to talk about having different flexible working arrangements, more flexibility, and people working from home, say 2 or 3 days a week. Does that become the norm that the likes of Richard, Florida and others are talking about? And if that is the norm, what does that mean for these buildings and those industry mixes? So I think being able to see Hoon's methodology here and how that might be applied with a very changing landscape with commercial tendencies will be interesting to see what unfolds.
Yeah, have you got a response to that interesting point, Hoon?
Yeah, thanks, Chris. That's very important questions amid COVID, and we will get new data set, which is this year, 2021, and that clearly show that how this ecosystem is changes during COVID time. And yes, that is another good questions, and I should consider in further study.
Great, thanks, Hoon. We'll leave it there for now, and I'll hand back to Chris to introduce the last speaker for the session.
Thanks, Sharon. So I guess we're heading back to Sydney, University of Sydney, with Somwrita Sarkar, who is a senior lecturer at the University of Sydney in the School of Architecture, Design and Planning. And Somwrita's presentation title I've mentioned before, but Somwrita does a lot of work across transport, housing, complex systems, smart urbanism. So Somwrita, over to you.
Thanks, Chris. Two really interesting presentations there. I'll start sharing my screen. So is the presentation visible now?
It is.
Thanks. Yeah, so that's a mouthful, but I was just thinking, one thing that has often intrigued me as we work with these, really interesting new big data sets is this question of where does a normative view cross over with a scientific objective view? So one of the things that we've been really thinking quite deeply about in our research group is this whole question of what is equitable urban growth. So if we are using all this city analytics and all of this, big data and new types of algorithms, and there's such interesting stuff we can do with it, but we know also that the decisions that we take in the planning space or in the design space have real implications for what it means for an ordinary person's life in the city. So one of the things we've been looking at is this idea that urban expansion and polycentric growth, which is happening in rapidly growing urbanizations increasing. And what it does is it can affect access to jobs and it can affect access to social infrastructure. So, things that we regularly require in our daily lives, our children go to schools, we go to libraries, we need hospitals and parks and so on and so forth. And the way these things are so spatially distributed affects social justice and equity. And so what is the relationship between city analytics and equitable urban growth, whatever that is, however we might like to characterize it? And so I guess a research gap here is that when we look at traditional data sources, we only see that the data is available once every 5 years or once every 10 years, depending on the country. And so many of these indices can only be developed and measured at those census periods. But we now have new big data sources. And the question is, can we employ this relatively more real-time, higher frequency, finer spatiotemporal data to track urban growth, population growth, and accessibility to jobs and social infrastructure at finer scales? And then the COVID thing is really wanting to leave it at a discussion point where we say that now that we do have these data sources available, and they are fine spatiotemporal, because we can track changes faster, what does that mean for algorithm design when extreme events happen? So if I can see like quarterly data and in buildings growth, can that, and I also know that there's a sudden drop in immigration, for example, during COVID in a certain country, how does that pan out for my algorithms? What are my algorithms showing? How does prediction, can we make prediction more reliable or more adaptive or more resilient in that sense? So with that short introduction, I will, I would like to acknowledge, as I said, so I planned this thing rather like a story, and I hope I can finish in what I thought would be 20 minutes. But if I am going over time, please let me know and I'll quickly try to finish. But I planned it like a story, and I would like to acknowledge that this presentation brings together some bits of our research on a larger scale project on polycentricity, accessibility, and equitable spatial urban growth. And I would like to acknowledge my colleagues, Professor David Levinson, Dr. Emily Moylan, Professor Nicole Gurran, Hao and Rashi, our PhD students and research associates. And I have a bunch of publications there and the grants that are associated with this work. And so the first, where this thinking started on crossing normative with the objective was when I started looking at complexity theory and the effect of city size on urban indicators. And as Hoon was presenting, I was just thinking that's such an excellent image of agglomeration, of economic agglomeration. And when we think of cities, we think that is where economic agglomeration happens. Cities are a physical manifestation of agglomeration happening. And so as cities grow, we often think that they show a higher than proportional increase of wealth and economic output for lower than proportional increases of input. So you put in less and you get out more. And that is the whole reason for having cities. And in quantitative geography, in physics, in urban science, this idea is captured in the form of what we call scaling laws. So when we think of cities, we think of this, and we often forget that, one form of agglomeration is this, and this coincides with, say, what Hoon was showing us. And the other part is also this. This is also a form of agglomeration, right? This is also our cities. And so what is happening here? And so looking at urban scaling laws, this is like a short introduction. We think of city size versus any other urban indicator. And if I have a 45-degree line there, that basically says, as my city grows, something else, income, wealth, anything that you might want to measure is growing on the y-axis exactly in proportion, one-on-one proportion with my city size, right? But what was observed is, and this is a pretty famous piece of work in the literature by Louis Betancourt and his colleagues. And what was observed is that as we put in economic inputs, if we measure economic inputs, like lengths of roads, anything that goes in to maintain a city or to build a city, the growth is sublinear. So we put in less actually to build a city. But if we actually look at outputs, we look at economic outputs, the growth is superlinear, right? So the idea is that we have scaling laws which basically say that cities exist because we put in less input to get more output, right? So therefore, having larger and larger and larger cities is an excellent idea because larger cities are more efficient, they are more innovative, they are more productive, they're more diverse, et cetera, et cetera, et cetera. And so it makes sense to invest in larger and larger cities, right? But some of the work then that we did, I was thinking about, you know, if I think of a rich person versus a poor person, going back to this equity idea, how does a poor person perceive a large city and how does a rich person perceive a large city? And so we did this kind of scaled hierarchical analysis where we started looking at different income groups, and sure enough we found that yes, larger cities are much more very like they're wealthier, but they're also much more unequal, because if you're poor, your growth is pretty much linear or sublinear, but if you're rich, the thing on the right shows that your income is superlinear. So if you're a rich person, your income indeed does grow superlinearly with city size, but if you're a poor person, you're either linear or sublinear, right? So you're worse off if you're poor and you're pretty much well off if you're rich, right? So if this is what some of complexity theory is telling us, then we get into this whole question that if we now start to look at the insides of cities as they grow, what do spatial inequalities imply for the lives of people? Because we see that jobs, housing, and social infrastructure are clustered and unevenly distributed. These effects get even more and more pronounced as city sizes grow larger. And therefore, accessibility becomes a key concept in measuring and tracking these inequalities. Because the hope is that if we can measure accessibility to, you know, some of the critical elements like jobs and social infrastructure and housing and labor, then we are providing a very rich evidence base for better planning, which might lead to more equitable city growth. So city analytics needs to effectively, reliably measure and track at very fine spatiotemporal scales exactly how urban growth is occurring. So we want to measure polycentric growth and how accessibility to jobs and social infrastructure can be related to this polycentric growth. So that being our objective, we'll break it apart now into two parts: jobs and social infrastructure accessibility. And I would just walk through one example here. We've done this for a number of cities across Sydney and the US, but I'll just take Sydney as an example, as for demonstration. So we all know that Sydney is proposed to be polycentric. And one of the questions we began asking is Sydney, because we want to aim for these 30-minute cities where everybody, whether rich or poor, gets equitable access to anything that's required for a good life. So we asked the question that, is Sydney naturally polycentric, or is it very, very monocentric still? And so we also observed that the traditional definition of locational activities in terms of measuring employment densities, the traditional definitions of measuring polycentricity did not really take into account flows. So we began looking at network-based metrics for measuring polycentricity, and we developed a set of accessibility-based and trip density-based measures, which basically capture the idea that a center is a location where the net inflow of workers is more than the net outflow of workers, right? So that's a little chord diagram showing an example. The one on the left is Sydney CBD, and the one on the right is Parramatta. And Parramatta is often named as the second CBD. And you can see just visually how big is the difference between Sydney CBD and Parramatta from the 2016 census data, right? So that's that. I mean, when that happened, when that figure was generated, I was like, whoa, you don't expect to see that big a difference, but there was. And so this is just some visuals that I'll walk you through. We developed 4 different measures for measuring polycentricity: trip centricity, density centricity. I do not have the time to go into the details of each of these, but then we had transit access centricity. So how many jobs minus labor access as a proportion of total trips when I take transit options, and then automobile access centricity, the same measure, but I'm now traveling by automobile. And basically each of these maps is measuring how much of the city becomes accessible to me, and how many jobs are available to me and how much labor is available to me if I live at a particular point in the city. And you can see that suddenly, like if I just look at the difference between transit and cars, that's a pretty crucial difference. So if I have a car, suddenly so much more is available to me. And if I don't, if I just decide to use transit, very little is available, right? So, and then we started looking at centricity distributions, and we basically found that accessibility, this was really an intriguing result, that accessibility centricity is bimodal, because if you see this particular, the last figure here, accessibility around Sydney CBD is extremely high, right? And then there's a discontinuous gap, and everything else like Parramatta and all the, Chatswood and all the other centers of employment, big centers of employment around the Sydney region have significantly lower accessibility centricity, right? So that was not, like this curve is not even continuous, where Sydney CBD is way, 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 way ahead of, anything else. And there's a discontinuity, and then, all the rest of the centers follow, right? So that really intrigued us as well. And we saw that the existing real structure is very, very different from what is currently proposed in the plan. So one of the unexpected outcomes of this work was that you could actually use city analytics and this whole idea of using data for performance evaluation of your plans. So I have a plan, I have proposed a polycentric Sydney, but how do I continuously evaluate whether the plan is achieving the targets of what it proposes to achieve, right? So we found that the existing real structure is still a very dominant monocentric central business district, plus a large proportion of dispersed employment, right? So for example, the policy takeaway was that the current economic geography of Sydney is not naturally polycentric, and significant land use and transport network shifts would be needed to realize the proposed Three Cities plan. And the scientific takeaway was interesting for us because, it provided more, it provided basically novel indices to measure polycentricity. And so from jobs, access, and sort of urban structure, we now go to a more, livability sort of concept, where one part of my life is I go to work, the other part of my life is I actually send my children to school and I need to go to a park and so on and so forth. So access to jobs versus access to social infrastructure. And this work was done as part of an Ahuri grant, and the final report is still under review. So yeah, and technically I should mention that just for this part of the presentation, I have been advised that I've been advised to request no keeping of the data till the Ahuri final report is released. So I would just like to mention that. So looking at accessibility to social infrastructure, this is the part where the big data, fine scale big data picture really came into play, because we said usually, okay, in the previous part, we are looking at accessibility just by, SA2s or SA1s or mesh blocks, and we are still at the area level. And we don't live at the area level, right? Because the street next to me could have access to really good bus services, and I have to walk maybe 10 minutes extra, but adding that 10 minutes to my 1 hour journey really has a large effect, whereas somebody living on the street next to me in a different building could have a much higher accessibility. So essentially what I'm trying to say is that I could look at accessibility at a very, very small level, fine spatiotemporal level at the building scale. So we began to use this geoscape data, which maps around 15 million building points across Australia. It's claimed to be an exhaustive database, which means it maps every single building more than 9 meters square of roof area, right? And so we began to then use the idea that if I look at how buildings are growing, because I have this data very much near real time. So every quarter, I know exactly how many new buildings are built at what points in the city. And if I begin to look at the rapidly growing periphery, the priority growth areas in different cities like Brisbane and Sydney and Perth, then I can begin to kind of project if n number of new buildings are coming up, then how much of population can I estimate will grow in the coming few years in this area, right? So my population estimation now has a variable which says, not only do I look at births and deaths and immigration and all the traditional demographic variables, but I also begin to look at buildings growth as a new indicator for population estimation. And using these new population figures at the mesh block level, we then started computing accessibility to social infrastructure. So schools, hospitals, essentially parks, and so on and so forth. And we were able to come up with very, very fine maps for leads and lags and deficits of social infrastructure by very small area in 3 cities across Australia. And this was supposed to lead, this is eventually going to lead to, I mean, this is not part of the grant, but it's going to lead eventually to a design planning coordination tool where a certain local government area could look at, very, very small area and say, okay, if I wanted to do, a projection on how many children would go to school in the next, say, 5 years, what am I looking at? And because also a coordination tool, because at present, this is the feedback we got back from local and state government, that there's really a deficit of information flow between at the local level versus the state level, right? So that being the general idea. This is just an image showing that a lot of the population growth is happening at the peripheries of Sydney rather than, and maybe a lot of cities around the world are going, maybe having this signature that a lot of growth is happening at the peripheries, and the population growth, the dwelling growth is echoed by the population growth. So we can see that significant dwelling growth is happening. This is still the census data. When we come to a correlation analysis, an interesting thing that we see is that some areas have really, really bursty activity. So this is a suburb called Coberty-Leppington, and it has seen an explosion of populations and dwellings for some reason in the past few years, right? So it's just interesting to see that some local areas would behave very, very differently to the region in comparison. And so we are kind of seeing this burstiness in the activity spatially. So now moving on to the geoscape, this is just a snapshot of the geoscape data for Australia and Sydney. And we have, as I said before, there are about 15 to 17 million points capturing every building with a roof area of more than 9 meters square. And what we did was we agglomerated each building, like each building has a land use label. So whether it is residential or commercial or institutional and so on and so forth. And we could agglomerate that to mesh blocks. And we compared usual residents per square kilometer to dwellings per square kilometer. And you can see that the residential component in the growth areas far outweighs any other use, right? So one primary takeaway there was there's a huge amount of residential growth happening, which begs the question that, you know, if employment centers are not growing at the same rate as residential, then we are actually creating this inequity, inefficiency in terms of how much people have to travel to get to work every day, right? So that, and this kind of related back to our finding on the polycentric Sydney, where we found that Sydney CBD is still pretty much leading every other center. So, so going on again, yeah, and I was just talking about this, I'm a little bit sorry I'm rushing so much because there's so much work, and again, you know, just trying to capture snapshots of it. This is trying to capture that there is very bursty growth. So you can see that if you look at different quarters, you'll find these bursts of buildings appearing at different very, very local areas. And so when we look at this as an area level statistics, it kind of gets smoothed over. But on the other hand, if I'm looking at accessibility calculations, it really makes a huge difference, because where I provide that next bus stop, where I provide that next primary school is very related to extremely local characteristics of where new housing supply is being produced, right? So again, another zoom in showing the bursty kind of activity. And so we were able to track mesh blocks and rates of growth in mesh blocks, say between a 1-year span, which captures 4 data points, right? August 2018 to July 2019. And we see that some local areas are registering way faster growths than many of the others, right? So again, there's this kind of heterogeneity, this kind of unevenness in the way that growth is happening. And this has an effect on access and eventually equity. So again, you know, areas of buildings, so number of buildings, areas of buildings. And so from
sorry,
here,
Somwrita, 3 minutes if we could.
Yes, yes, I'm almost to the end. Thanks, Chris. So yeah, and so using this idea, we used, as I said, we have a population estimation model which uses buildings growth to estimate population across for these time points. We calibrated that with the ABS, the resident population ERP statistics, and then finally we compute accessibility. And this is like saying, very simply, how many primary schools or how many hospitals can you access within 10 or 20 minutes of walking distance from the centroid of a mesh block versus, or another question could be, how many usual residents can a school access within 10 to 20 minutes of walking distance, right? So my home as the center versus the school as the center, 2 accessibility computations. And I'm going to quickly walk through, I'm going to maybe skip through the methodology, just cover it in like quickly. We computed travel times between mesh blocks for 3 modes, walking, transit, and driving, and using transit timetables, GTFS essentially, and OpenStreetMaps. And we have a database for median link speeds for every road link on Australia from November 2019. So we computed automobile times from there, right, to compute our accessibility calculations. And I'm quickly going to just walk through some, like a movie. So this is access to schools by walking. You can see the blue dots are all the primary schools, and the sort of gray area, the green gray area shows you the accessibility, the number of people that can reach. And 10 minutes goes to 20 minutes, accessibility increases. Transit accessibility increases further, but driving accessibility pretty much drastically increases. And then again, if I show hospitals, very, very poor accessibility by walking, 20 minutes, transit, driving. And essentially, you know, that was just planned like a movie. I don't really have time to dwell here on this more, but I'll be happy to take questions. But this kind of analysis really helps us to identify hotspots and leads and lags, where what areas, what mesh blocks, what little tiny areas are lagging behind and need more attention in terms of social infrastructure, and so on and so forth. I will end by just summing up, I guess, that a traditional database approach allows us to compute all of the indices above. So we haven't really done, we haven't really proposed novel indices, but basically what we have done is worked with higher frequency, finer spatial and temporal scale data. So we hope that this is useful in informing continuous planning. So like planning for locating social infrastructure in rapidly growing areas, computing accessibility to jobs, and analyzing equitable versus inequitable, efficient versus inefficient city structures. And as I said in the introduction, COVID, the Ahuri grant was funded before COVID, and then as soon as it was funded, COVID happened. So while we were doing all this analysis, we got a bunch of data from Geoscape before COVID, and then the next one that we are expecting, this is the interesting question, that if suddenly immigration takes a drop, or something extreme happens, and say my population, instead of following that sort of nice curve, projection curve, something drastic happens, how does this, I will leave this with a question, that how do these kinds of new data sources help us to think about algorithms and city analytics and indices, which can be more resilient and more adaptive? Like, if suddenly something happens to my building growth or population growth, how can I suddenly reflect that in my accessibility computation? And then how can that inform planning better? And can that enable planning to be more resilient and more adaptive more quickly and more, in terms of a response to an extreme event? So I will end there, Chris, and I will hand over.
Thanks, Somwrita. So Sharon, I noticed you're back online. If you, I know Sharon unfortunately missed the last bit of your presentation, Somwrita. Look, so thank you. That was really an in-depth presentation of a number of techniques, very novel techniques. It was good to see. I quite like the use of the Geoscape for those who are not in Australia, having, I guess, a big database, relatively big, of buildings, of all the buildings across Australia collected through satellite imagery processing, and being able to look at that to sort of ascertain industry mixes and agglomerations. I think it was an interesting approach, which I think if Hugh and Hoon got together, it'd be an interesting combination to be look at the vertical as well as the two-dimensional spread. So I think excellent sort of presentation. Then tackling some of those challenges of understanding equity in our cities and how we plan, and if we can design a more equitable city, and what does it mean from accessibility. So you've covered a lot there, Somwrita. Excellent presentation. Any questions? I'll hand over to Sharon to field the questions of your excellent presentation, and if we hopefully have some time, any other questions of Hoon and Jonathan before we wrap up.
Right, so I'm back online. I'm sorry to have missed the last bit, but I'll listen to it later on. Any other clarity questions, and then we'll open it up to a more general discussion for the last 10 minutes.
I got a quick question, Sharon.
Yes, Jonathan.
So just interesting, thank you, Somwrita. Just interesting, where are you taking this work next? What's that sort of next step?
So I guess one thing is a more continual. So as I said, when we received data from 2018, 2019, and then COVID happened. So one obvious step is that now if I look at 2020, what's happened? Has buildings growth continued in the same way? Have the patterns changed? Because certainly, immigration patterns have certainly changed. So how is that interaction between dwellings growth and population growth panning out in response to something like COVID?
Thank
right?
you.
And the other thing, of course, is that this leads to a number of other, like we have another project where we are now looking at movement of people. So not only, so, there is questions like as growth is happening, there is also displacement, and there is gentrification, and there is, those kinds of spatial processes. So because people are moving all the time, right? So you could then, as the next step, begin to look at who is moving where am I rich, am I poor? And if I was poor, how am I moving across the Sydney region or the Brisbane region or the Perth region or say any region? And how is that affecting my accessibility, right? And if I'm kind of being forced to move, then am I losing accessibility or am I gaining accessibility? And what does that mean for planning? Right. So, and then of course, there's this larger fundamental science question of I'm still thinking about that, but how does this all relate back to the complexity theory stuff of, city size, the effect of city size on urban indicators? So getting back to the full circle on the Lewis Betancourt, Geoffrey West, sort of challenging some of those ideas there.
Some busy work ahead by the sound of it.
Thanks, Somwrita and Jonathan. Then there's a question from Ling Zi, suggesting that there's evidence that city size is correlated to inequality. And are there any urban indicators that could be negatively correlated with urban growth that we need to take notice of for planning?
Yeah, certainly. So I was discussing economies and diseconomies of scale. So yes, wealth increases as city size increase. And what we showed essentially is that inequality increases as city sizes increase. But there's tons and tons of previous historical research that shows crime also increases superlinearly, pollution increases superlinearly. So there are it's very interesting. Paul Krugman explains it, I think, in one of his books, or I think Fujita and Venables. It's in a book which has this really interesting idea that there are centripetal forces that want to make a city, and there are centrifugal forces that are, acting as diseconomies of scale come in, right? So some of those negatively correlated things are crime and pollution and, inequality that actually prevent agglomeration from happening, and all the economic forces are causing the agglomeration to happen. And the city as we see it is kind of like this balancing between the positive, the centripetal and the centrifugal. So
I also think is industrial restructuring is a huge impact on cities' growth and decline. Now, for example, we've seen that those the post-industrial town decline 1980 and 90s, like here in Australia, for example, Newcastle and Wollongong, a big hit, those post-industrial air. And also, if you look at this COVID and also this smart movement, there is a lot of business actually transformed to new business, like startups. And for example, Smart Harbor or Silicon Valley, that types of clustering is a big thing, is changing urban form growth, but vice versa, conventional and traditional business and particular heavy labor intensive businesses also negatively affect urban growth as well.
They are, Hoon, but I think it's going to be interesting to see what happens when you just mentioned, the sort of the tech giants and tech in commercial precincts. And I know at the moment Atlassian and Google, at least in Australia, are not in their offices at all. And so when we start to look at a post-COVID, what does that mean for these tech hubs, these Silicon Valley like clusters that have been a driving force for many cities to try and have these sort of tech hubs as magnets for job growth? When we start looking at, I got colleagues at Google who manage teams in Canada, and there's obviously companies are global, and what is that going to mean for them having these central hubs of employment moving forward? So these will be fascinating times as we start to unpack this. And it's great we can get some of this data sort of pre and post COVID, Somwrita. But I think the challenge will also be is looking at the lag of, building and government incentives and policies, because government seems to be, we've got at the moment in many parts of the world, which is fantastic to see, some innovation in investments in pop-up open spaces and pop-up cycleways. But we're still seeing typical infrastructure projects where they'll be investing billions of dollars in metro systems, which is good. It's better than, from my perspective, better than cars. But how many people are going to be using these metro systems? What's going to be the future demand of these metro systems? When at the moment, if I want to go to the Sydney Opera House and see a performance, I get a message saying, please do not catch public transport. Please drive your car and we'll give you discounted parking. So I think it's turning things upside down.
Yeah, that is such an interesting point, Chris, because I actually calculated, if for a family of 4, the train tickets are almost as expensive as just driving and parking there. So, because if you have to catch a train and then a bus, you're pretty much better off just driving the car. So
I think these policies, government policies to invest to keep jobs, and then what they're investing in, and then social distancing, it's all very complicated and mixed. And I guess we're very fortunate in Australia, in Oceania. I guess we will have to say we're exceedingly fortunate with our COVID-19 situation, and so how that plays out globally as we compare how people are social distancing and how cities are responding and reforming or moving and centralizing or decentralizing is I think there's years of really important research for us to consider.
So Ying, do you wanted to end 5 minutes earlier? Do you want us to stop now, or do we still have 2 minutes for some wrap up?
Well, according to my clock, you have 3 minutes more. So absolutely, it's a brilliant session. I'm really enjoying it, and yeah. So you have
so
time to wrap up. Absolutely. Yeah, that's right. Yeah.
So to me, what I extracted from all 3, which they were all just coming at things from such a unique perspective. They all had brilliant graphics and visualizations, and were all using big data and data differently. What I heard commonly, though, is that next steps, we want more data, finer scale, over smaller timeframes. And my question, and I think Somwrita, when you raised the normative, I was thinking the fit for purpose. So we can always do more data, more detail, bigger data, more pretty graphics. But again, the fit for purpose of it, and that's why I asked about the toolkit. So what is all this for? And all the discussion around COVID and that. So I just wanted to probably end off by challenging each of the speakers to say, how much more do you need to go? And we also need to bear in mind that we need to know when to stop and when is enough, because we can't, we can technically carry on with all of it, but does it always mean something? For example, Jonathan, what I was thinking of when you were talking was the whole good old SEPTED, crime prevention by urban design. And what your big data has done is it's allowed a whole new analysis there. But fundamentally, some of the principles and the storylines, like the more sight you have on a place, the better it is for crime. So how much more are we actually adding to the debate by all this more and better big data? So I suppose just to one sentence from each of you on this big data, how much is too much, and that element of normative and fit for purpose. So can we just finish with Jonathan first, then Hoon, and then Somwrita?
Thanks, Sharon. Great question. Look, I think in terms of the increasing granularity of the data that we're able to access through these different emergent sources allows us really to tackle the dynamism, I think, in a way that we haven't been able to previously, to sort of unpack the nature of thresholds and change points. And I think that sort of connects through the 3 presentations. And I think that really is a sort of a driving goal. And I think we need to, on the one side, have good hold on, increasing complexity isn't necessarily always going to herald better outcomes. And so I think holding that sort of that social outcome or that economic or environmental outcome up high, and then always questioning whether or not, increasing the granularity is able to unpack that in new and important and useful ways. So I think the practicality needs to be kept in hand.
Great, thanks, Jonathan. Hoon, 2 sentences.
Yeah, I think there is a vast of big data analysis methodologies and the novel approaches, and because it's a big data, can be any forms, any scale, any speed. Well, I think it's important we share this or exchange knowledges is our latest or advanced technologies in big data analysis that I want to emphasize.
Thanks, Hoon, and Somwrita.
Yes, it's such an interesting question. How much is enough? And I would say we are, just by the nature, the complexity of evolution of our societies are such, it's infinite. So we are going to continue to generate infinite amounts of data. And therefore, just because we are generating it, someone is going to use it, right? But the question, the interesting question for me is, how are we using it? And as researchers, are we very conscious of how we are using it, right? Because I could easily build something that becomes a speculation tool in the market, and I could easily use the same piece of data to inform better planning and better equitable outcomes. So the question is, so if a commercial company uses the data, they would use it in a very different way. And if a researcher uses it, so the question is, are we all consciously using the data? And while we are doing the research, are we even aware of all those normative ethical questions? I guess that's, yeah.
Brilliant, thanks. And then Chris, for the final word from the chair.
Thanks, Sharon. 3 excellent presentations. So thank you, Jonathan, Hoon, and Somwrita. And it's interesting because big data, as you said, Sharon, is one of the common themes that supported the research presented. I'm left with thinking around the temporality of the data. And we know with census data, a lot of these techniques are still very valid in understanding what's happening in our urban spaces, is collected every 5 or 10 years. And what the 3 presentations have shown and highlighted the need for more fast and efficient forms of collecting that data and processing it. If we're looking at disruptive events like COVID-19 or bushfires, and how we quickly respond and how we have resilient cities, we need, there's the veracity and the size of the big data, but it's that temporality, getting it quickly, getting the smart card data quickly that Jonathan's looking at, getting those survey data sets and 3-dimensional data sets that Hoon's presented, getting the satellite imagery and the building growth and city growth that Somwrita's presented. So I think that's still a challenge and opportunity if we're using our cities as living laboratories. Thank you so much to the 3 presenters. We didn't have anyone from New Zealand, but I was just reading an article by Mark Gagan over at Auckland University, New Zealand. And I would encourage everyone to look at a recent publication that he has just put out there, the 4th paradigm of geoscience, where he starts to look at moving from empirical science through to theoretical science into computational science, and more recently into data-driven science. And I think the 3 presentations today have really highlighted the potential and possibility of what is required to help address some of the challenges facing our cities if we're using this data-driven science approach. So thank you, everyone. Thank you, Ying. Thank you for the Martin Centre, Cambridge University, for organising this online global conference. I look forward to future sessions, and thanks for everyone's time and participation.
And thank you so much, Chris, and for curating such a wonderful session. So this has gone so well that we must do it again. The only condition is that next time, if we could have some speakers from New Zealand as well, so that I think we should probably have a longer workshop for this, and a huge amount of material and all these memes about the familiar strangers and the occupation of buildings, and also the future of urban agglomeration, are fascinating topics to understand. Maybe this is really a good moment also to quote from Professor Jianping Zhou from Hong Kong University, who typed in just a question about the need for new data. Yes, absolutely. But I think what I would add as one sentence is that it looks that we ourselves as urban analysts and modelers will need to collect and curate this data ourselves. In the past 3 days, I've been attending the UK Office of National Statistics conference on data. They themselves, being the data providers, were saying that the data is lacking. And I think this is one of our greatest challenges going forward. So, but I could see the enormous amount of power that is emerging from this field. So, and also the acceptance to analysis and modeling has greatly increased all over the world. So I think we should actually do well to ride in that tide. I'm conscious that the delegates of the next session and speakers actually have emerged in this workshop, and very much a welcome to the delegates. And in a while we will introduce everyone properly. But for this moment, I think what we should do is to suggest that for all the colleagues attending, we could have a very brief comfort break. So perhaps go and load up your coffee and stretch your legs a little bit and come back at 5 minutes past. We will start the next session.